So let me talk about a couple of things that we're going to change second semester, okay? Just, first of all, a reminder, you get 4 bathroom passes, right? Every one that you don't use, you get 5 extra credit points at the end of the semester. So you can get 20 extra credit points, all right? We talked about this first semester, I had a bunch of people not remember that, I guess, okay? So I won't really talk about it again, but I'll just take these sheets off the door at the end and count how many points you get, I guess. We're gonna change the way that we grade, that we assign grades for this class, which really I went back and calculated it last semester, and most of your grades would have stayed exactly the same, okay? But we're gonna divide everything into 2 categories. It's either gonna be homework or it's gonna be a quiz. The homework stuff, labs are gonna be included in homework, okay? And tests will be included in quizzes. That was the only way that I could do it. They wouldn't let me rename the categories. So we're gonna make homework worth 50% and tests and quizzes worth the other 50%, okay? And the main reason I'm gonna do that is because I feel like this semester there's a lot more tests and quizzes, and I don't want people to fail. I think last semester we ended up with like 4 tests for the entire semester. I think this semester there's like 6 or 7 tests, okay? So I don't want that to be a huge bearing on your grade, right? Does that make sense? I want the homework to be worth a little bit. All right, any homework not turned in before the next day is going to be worth 50% of what it was. All right, so any homework not turned in before I go over it. So we're going to have a couple of assignments today, one thing from the book and a worksheet. And those are going to be, if you turn it in after the start of class, it'll be worth 50%. Okay, so I think they're worth a total of 14 points altogether. So if you turn it in tomorrow, let's say at 9:10, okay, you'll get 7 out of the 14 points, no matter how well you do on it. A lot of the homework stuff, I just give you participation. I do grade a few of them, okay, but if you just will try it and turn it in, you will get the points. Now I go through and look to see, I read your answers and make sure, this is ridiculous, you just made that up. Okay, I don't give you points for that. All right, so you guys have any questions? So we're going to change things a little bit.
We're still going to turn it in on Canvas, right?
Yes, we're going to turn everything in on Canvas just like we have been. I don't care if you do a video, but make sure I can see the video. I would much rather you submit a picture, like use your cell phone, take a picture of it and submit it that way. It's a lot easier to see. Or if it's a short assignment, just type it in there, okay? And that helps me a bunch, okay? Because those videos sometimes are terrible. And I think it would really help if you had good light. I know I turn these lights off here in the front in this class, and it makes it kind of hard to see anybody that does a video over here. But it's hard to see the screen if I have the lights on. So that's why I usually have them off. So, on the next page in your comp book, please write this in. We're going to start talking about bonding and naming substances. Sharpie? Yeah. Green okay? Green okay?
Yeah.
Just put that one. Addie, I'm also going to record this and put it on YouTube too. So if some days this doesn't work, if you let me know ahead of time, I'll set up my GoPro for you, okay?
Tomorrow I have a doctor's appointment, so I won't.
Okay, so email me at the end of the day, and I'll try to remember to set up the GoPro, and I'll just put it on YouTube and you can watch the video, okay? So I don't really know what the best way to do this is. On Canvas, if you look at the announcements, it tells you what we're going to do. I'm not sure that you're going to be able to see these notes very well on here, but you can copy them off of Canvas and you can just listen as I talk about it, okay? So here's the notes over ionic and covalent bonding, and I'll try to stay by the computer, but I have a tendency to wander around. But this is on pages 183 and 190 in your textbook, so I linked that for you. And by the way, you guys can take off your masks if you want to, because we're social distanced, okay? You don't have to, but if you want to. You'll need to answer questions 1, 4, 5, and 7 on page 190. What always happens is, every time there's a new section, not every time, but sometimes when there's a new section, the old section has questions that always end up being on the first page, and I always have people that submit the answers to those. That's not what I want, okay? So we're really going to talk about 3 different types of bonds. We're just going to mention metallic bonds, okay? We're not really going to test you over them. If you want to take chemistry, you can talk about those. But the objective here is to understand what ionic and covalent bonds are. So the whole reason why atoms bond is so they have a stable electron configuration. And to be chemically stable, how many electrons do atoms need to have in their outer shell?
0.
Okay,
0 or
so,
8, yeah.
some of them can have 0, but if you go back 1, it's going to be 8, right? So we'll say the outer shell is 8. With the exception of a couple of them, hydrogen and helium only have to have
1.
2 to be stable, right? Because hydrogen's here, it has 1, helium is over here, it has 2. Lithium, actually, it's going to lose 1 and have 2. Beryllium's going to lose 2 and have 2. So there's several of them that can be stable with 2. The first energy level, you only have to have 2. After that, you have to have 8. And so the reason why elements combine and form bonds is to become chemically stable. All right? So there's 2 types of bonds. There's ionic bonds and covalent bonds. So let's start by talking about ionic bonds. Ionic bonds form from the attraction between oppositely charged ions. We talked about last semester atoms of the same element with different numbers of neutrons were called what? Anybody remember?
Wait, what?
Atoms of the same element with different numbers of neutrons. What are those called?
Isotopes.
Isotopes. Atoms of the same element with different numbers of electrons are called
Ions.
ions. So 2 I words, right? What about atoms of the same element with different numbers of protons?
It'd be different elements.
It'd be a different element. Okay, that's a trick question. Okay, if you change the number of protons, you change the element. All right, I'll move this up a little bit. Is that what you need me to do? Right.
Are we ever going to talk about quarks?
No, not in here.
Okay.
Okay. We may mention them. So in ionic bonds, this forms the attraction of between oppositely charged ions. So you get positive ions combining with negative ions, right? Opposites attract in terms of like the poles of a magnet. That's what happens when compounds form ionic bonds. And so when an ionic bond forms, it forms between a metal and a non-metal always. And the way you can tell, I had this question last hour, we talked about the difference. There's a stair-step line on the periodic table. Anything to the left of that stair-step line is a metal. Anything to the right of that stair-step line is a non-metal. What about things that are on the stair-step line? What are those called? Metalloids or semiconductors, right? And we're really not going to deal much with those, okay, because they kind of act a little bit differently. But if you see a metal bonded to a non-metal, it's an ionic bond. Metals have a tendency to lose electrons. Non-metals have a tendency to gain electrons. And so you get positive charges of metals combining with a negative charge of non-metals to form an ionic bond. And these form networks, not molecules like covalent compounds do. We're really not going to get into that. We're not going to get into the structure behind ionic covalent bonds. We're just going to mention it here. Ionic compounds have a tendency to conduct electricity well when they're melted or when they're dissolved. They have a very high melting point for the most part. And some examples will be things, well, one thing that you're very common with, NaCl, which is sodium chloride, which is just table salt, right? Na is right here. Cl is all the way over here, so that's a metal and a non-metal bonded together. Calcium fluoride, Ca is right here. Calcium is a metal. Fluorine's a non-metal. It's right here. That would be an ionic compound as well. The other type of bond is a covalent bond. This is where we have bonding of atoms through the sharing of electrons. So instead of electrons being given up or taken, now electrons are being shared. And this happens only between nonmetals. So when you have two nonmetals combined, okay, it's a covalent compound. So that's really what we're going to use to tell the difference between ionic and covalent bonding is the types of elements that are combined. So if we have two nonmetals, it's covalent. A metal and a nonmetal is ionic. So covalent compounds, or covalent molecules is what we'll call them, have low melting points and they don't conduct electricity. There's really three different types of bonds. We can have single bonds, double bonds, or triple bonds. If you have, for instance, I don't know, two chlorine atoms combining to form a covalent molecule, chlorine has 7 valence electrons. So each one needs to have one more. And so what they basically do is share one electron. They have a single bond. Okay, if we go over one and look at oxygen, oxygen has 6 valence electrons. So oxygen to become chemically stable would need to share 2, so it would be a double bond. Nitrogen has 5 valence electrons, so it would need to share 3 and form a triple bond. Okay, does that kind of make sense? We're really not going to dig too deep into that, okay, in terms of the bonding. What I really want to emphasize this chapter is the naming, because that's going to help us as we go further. Now, when electrons are being shared, they're not necessarily always shared equally. If it's two different elements, one element always has a tendency to want the electrons more than the other one. Okay? And really what we're going to say, it's more complicated than this, but what we're going to say is elements that are closer to having 8 have a greater affinity for those electrons, for now. Okay? It's a little bit more complicated, but that's kind of what we're going to use without teaching the rest of it. And so if we have carbon, which is right here, it has 4 valence electrons, combined with oxygen, which is over here, which is going to want the electrons more, carbon or oxygen? Oxygen, because it's closer to having 8. Okay? If we have 2 oxygens bonded together, well, they're the same element, so they share the electrons equally. Metallic bonds, we're just going to mention. This is the combining of metal atoms, how metal atoms combine together. And really, in a metallic bond, all that happens are the electrons are free to flow from atom to atom. And this is why metals conduct electricity so well, because we have all these free electrons that are allowed to move one way or move the other way, which is what electricity is, right? It's just atoms being able to move one direction or the other. And then polyatomic ions, this is kind of a unique idea or concept. Polyatomic ions are covalently bonded atoms that end up having a charge. Okay, so an example of that, which I didn't talk about this in the regular class, but an example of a polyatomic ion would be SO4 minus 2. So that's a sulfur and 4 oxygens combined together, okay, sharing electrons, but they end up having a charge. And so we treat a polyatomic ion just like a single atom ion, okay? So don't be confused if you see that. We're not really going to get into it, but if you take chemistry, some of you will take chemistry next year, some of you won't take it for a couple years, some of you may not ever take it, but you'll have to go through and memorize a lot of the polyatomic ions and what their charges are and be able to name them, okay? Okay, because if we combine this with, I don't know, potassium. Okay, this would be potassium sulfate, is what this would be, because this is a sulfate ion, okay, polyatomic ion. But we're not really going to get into that, but if you see something like that later on, where you see, what would it be? It'd be K2SO4. Don't be confused by there being 3 atoms in there. It's just a polyatomic ion is what it is, okay? So they're covalently bonded, forming an ionic bond with something else. Yes?
Does the weak force have anything to do with, like,
Yeah, it does. We're not really going to get into the different, we will when we talk about forces, okay? Which is really what holds things together at a molecular level,
right?
okay? Weak nuclear forces and strong nuclear forces and all that stuff, but that's more physics related.
Yeah, because I was kind of curious how the two work.
Right.
The strong and the weak force.
Yeah. So we're not really going to get into that because it gets kind of complicated once you get to that point. So, any questions about those notes? Okay, so get on Canvas and click on the ionic covalent bonding section, and you'll need to answer 1 through 4, 5, and 7. You can read pages 183 to 190, and then there's a worksheet. I think it's called Bonding Worksheet 1. Addie, you'll have to use it off of the internet, okay? But you should be able to open up this too, this worksheet, okay? And answer the questions and submit it to me. All right? So I'm going to leave you, I'll probably be wandering around the room. If you have a question, just say something, okay? If you type it into the chat, I might forget to check it. But I've got you, I think you can unmute yourself, so just ask, all right? Okay.
Can I go plug my Chromebook?
Yep, if you guys need to plug in your Chromebooks, why are you using that one back there? Just go to one of the back tables. And you might be able to, Quentin, can you reach that one, that plug-in over there? I don't know if your cord's long enough.